Okay, welcome. Bismillahirrahmanirrahim. So आज हम बात करेंगे about the buffer solutions. ये एक important topic है. No, it's a very important topic as far as the practicals are concerned, the understanding the various aqueous media is concerned, and also from the competitive examinations point of view. So straightforward, let us talk about some basics about these and the important points regarding the exams. Okay, we'll start. Introduction to the buffer. Buffer क्या होता है? It's a solution. Simply यानी आपने कोई solute लिया है, it's some sort of solute that you dissolve in some let's say water, ठीक? So that becomes a solution. So it's that solution which can resist pH change upon addition of an acid or basic components. Means एक ऐसा solution है जिसमें आप if you add small amount of acid, small amount of base, so it will resist the change in pH. हमने इसको पहले भी डिस्कस किया हुआ. The moment you add some amount of acid or base to any solution, the pH gets changed. But अगर उसी solution में आपका ये buffer है, so it will not make that much change. It will not let the changes to happen. So we should say it resists the change. So it's called a buffer. So it's able to neutralize small amount of acid or base. जिसे हम बात कर रहे थे that you add minor amount of acid or a minor amount of base. So what is that? It has a tendency to neutralize that. ठीक है? So we should say it maintains the pH of solution relatively stable. Means what you do that जो आपका solution है, जब भी आप कोई एक्सटर्नल केमिकल कंपाउंड उस पर ऐड करते हो, इट्स पीएच गेट्स चेंज्ड. बट अगर आपने इसमें पहले बफर ऐड किया हुआ है, now what it does, it stabilizes the pH also. So this is what buffer is interesting. Now the striking example of buffer is that human body. We know that in the human body we have carbonic acid equilibrium which is existing in the blood. कैसे बनता है? In shortcut, the carbon dioxide it will take from the atmosphere through the lungs, and then it goes into the blood. Now inside the blood, this is what is happening in the blood. Carbon dioxide combines with the water, it forms carbonic acid. Now this carbonic acid gets dissociated into H positive and bicarbonate. And then you know that bicarbonate can be in the form of sodium bicarbonate or bicarbonate anion. Now this bicarbonate, it's basically performing the role of the buffer in the human body. We know जो ह्यूमन बॉडी में ब्लड है इट्स क्लोज टू द बेसिक पीएच 7.5. सो ये जो बफर है एंड दैट बेसिक पीएच, मेंटेनिंग दैट बेसिक पीएच इन द ह्यूमन ब्लड इज वेरी वेरी इंपॉर्टेंट. इसको मेंटेन करने में जो इंपॉर्टेंट रोल प्ले करता है दैट्स योर बाइकार्बोनेट बफर. सो दिस इज द स्ट्राइकिंग एग्जांपल वन कैन रिमेंबर. नाउ टॉकिंग अबाउट टाइप्स ऑफ बफर्स, देयर आर टू टाइप्स ऑफ बफर्स. नंबर 1 एसिडिक बफर एंड नंबर 2 बेसिक बफर. Acidic buffer क्या होता है? A solution containing a weak acid, remember this, solution containing a weak acid and it is salt with a strong base. So इसका मतलब है that if we talk about the acidic buffer, we must have two components. Number 1, a weak acid and its salt. We know acid combines with the base to form salt. So a weak acid and its salt with a strong base, that is called as acidic buffer. एसिडिक बफर का जो पीएच है दैट इज इट मेंटेन्स द एसिडिक पीएच. मींस अगर आपके पास कोई ऐसा सॉल्यूशन है, यू वांट टू मेक इट रिलेटिवली स्टेबल, यू वांट टू कीप दैट एसिडिक पीएच स्टेबल, सो यू कैन यूज दिस टाइप ऑफ बफर. नाउ ये कैसे बनता है? यू कैन मेक यूज ऑफ वीक एसिड लाइक एसिटिक एसिड. वी नो इट्स अ वीक एसिड एंड you make the salt of that. You react this acetic acid with sodium hydroxide, you will get salt, sodium acetate. So combination of sodium acetate and your acetic acid, that gives you acidic buffer. So this is your type number 1. अब दूसरे टाइप पे आ जाते हैं, basic buffer. So a solution containing a weak base, तो इसमें जो component है that is weak base and it is salt with a strong acid. That's the basic buffer. So what it does, it maintains the alkaline pH, basic pH. If you have a solution, you want to stabilize it as, it's a basic solution, you want to stabilize the basic pH. So what you do, you use that buffer, that is basic buffer. Now, ये कैसे हम बना सकते हैं? We can make it with the help of weak base like ammonium hydroxide plus its salt with its salt, which is ammonium chloride. कैसे बना सकते हो? You react this ammonium hydroxide with HCl, you get ammonium chloride. So combination of ammonium chloride and ammonium hydroxide gives you basic buffer. So this is in general the types of buffers. Okay? Now let's talk about important term, that is the buffer capacity. Buffer capacity can be defined as the quantitative measure of the resistance to the pH change when H plus and OH negative ion, hydroxide ion, they are added to the buffer solution. जैसे हमने ये बात की कि buffer, what they do, they stabilize the pH of any solution. They do not, make it happen. They prevent the change in the pH. They resist the change in pH when you add some external acid or base to that particular solution. Now, अब एक क्वेश्चन है कि एक बफर के पास कितनी टेंडेंसी है, how much tendency. We want to measure that quantitatively, that the tendency of any buffer to resist the change in pH when some external base or external acid is added. Now that tendency is expressed in terms of buffer capacity. Okay? It's also called as alkalinity capacity or neutralizing capacity. It can be defined by this term beta. This is basically beta, that is equal to dC, that's change in the concentration, divided by dpH, change in the pH. That means, it means acid or a base concentration required to bring a change in the pH by 1 unit. What it means? जैसे हमने अभी कहा था, if you have a buffer solution, it has the tendency that it stabilizes the pH. It resists the change in the pH the moment you add the external base or acid to that particular solution. Now, if you add, every buffer has some capacity to resist the change. How can we measure that? How can we express that? The acid or a base, आप कितना acid or base add कर सकते हैं, so as to bring the change in the pH of solution by 1 unit. So this is how we express that the change in concentration that we need to bring, that is the amount of acid or a base which we need to add so that the change in the pH of solution occurs by 1 unit. That's called a buffer capacity. So buffer capacity usually किस पे डिपेंड करती है, किस बफर में कितनी टेंडेंसी है टू रेजिस्ट द चेंज, किसी बफर में कितनी टेंडेंसी है टू स्टेबलाइज द पीएच. नाउ इट डिपेंड्स ऑन द concentration of the species in the buffer solution. That means buffer solution में जो आप acid use करोगे या it is salt use करोगे, likely a base and the salt. Now what is the concentration of those species? That will decide the buffer capacity. If buffer solution is highly concentrated in general, अगर एक buffer solution highly concentrated है, what happens? So if buffer solution is highly concentrated, it will have greater buffer capacity. तो जितना concentration आपने use किया है buffer components का, that is acid and salt, likely base and salt, जितना concentration ज़्यादा करोगे use, then it will have the more buffer capacity, more tendency to resist the change in the pH. So it can be determined with the help of a process, that's the titration. And that's not a topic at the moment. We do this in the lab. Now let's talk about the mechanism of action. This is very important. So far what we have done, हमने ये discuss किया है that buffers have the tendency to stabilize the pH, or buffers have the tendency to resist the change in pH upon when you add external acid or external amount of base to that particular solution. अब ये कैसे work करता है, how it resists the change in pH, let's talk about. First one is the acidic buffer. Now this is your acidic buffer, acetic acid plus sodium acetate. जब आपके पास acetic acid and sodium acetate dissolved in the solution, you have obviously the equilibrium. Acetic acid will be involved in equilibrium this way. It gives H plus and acetate ion. So this is equilibrium number 1 in the solution. Second is when you dissolve sodium acetate, it gives sodium ion and acetate ion. लेकिन यहाँ पे important बात ये है, sodium acetate is a strong electrolyte, acetic acid is a weak electrolyte. That means acetic acid will be weakly dissociated, while as sodium acetate will be strongly dissociated. Now talking about the buffer action, Let us talk about first, we want to change its pH of solution. So let's add the H positive ion to this solution. When you add H positive ion to this solution, क्या होता है, जो acetate ion है, that takes this hydrogen ion, it is shown by this arrow. So it takes this hydrogen ion. What will it form? It will form acetate, simple word for acetate. And we know acetic acid, sorry, it forms acetic acid. Acetic acid is a weak acid. Its degree of dissociation is low. That means जो acid बनने वाला है, since it is a weak acid, so that automatically means it will not get dissociated. So obviously there will be minor change in the pH. Okay? Now, so basically this H combines with the acetate ion to form the acetic acid. Now how it resists the change with respect to the base. जैसे आपने base add किया इस solution को, we know that we have H positive present in the solution. That base combines with the H positive, so that forms water. And we know water also is a weak electrolyte. It is dissociation to H positive ion, and it is dissociation to the hydroxide ion is very, very less, since it's a weak electrolyte. So because there's water formed upon addition of base, it's a weak electrolyte. So weak electrolyte will not undergo dissociation. That means it will resist the change in pH. So this is how basically the acidic buffer shows the action, how it resists the change in pH. Second, basic buffer. Let's talk about the basic buffer. So basic buffer is, we have ammonium hydroxide and ammonium chloride in the solution. So obviously they will be involved in the equilibrium that ammonium hydroxide gives hydroxide ion and ammonium ion. And ammonium chloride gets dissociated to form chloride ion and ammonium ion. So this is what we have in the buffer solution. Now let's add H positive ion, external agent. जैसे आपने H positive add किया, we have hydroxide ion present in the medium. It combines with the hydroxide ion, it forms water. Now we know that water is a weak electrolyte. जैसे आपके पास weak electrolyte बनता है, that means its degree of dissociation is less. When its degree of dissociation is less, that means the change in pH will be minor. So this is how it prevents the change in pH by addition of external acid. Now base के लिए हम देख लेते हैं. With respect to base, you add this external base to this buffer solution. Now this time it combines with the ammonium ion in the solution and it forms ammonium hydroxide. Now ammonium hydroxide formed, we know it's also a weak electrolyte. So its dissociation is very, very less. Its degree of dissociation is less. That means the change in the pH will be also less accordingly. So that means overall it prevents the change in the pH of solution, or it stabilizes the pH of solution, even though we are adding external acid and a base in the form of H plus and OH negative. So this was about the mechanism of buffer action and the basics about the buffers. आज के लिए इतना ही. It's a concise series. If you have questions, please write down. So inshallah we'll go through that, we'll see it. इसके अलावा you can also check back. So you have this PDF file here in the description. So इसका note जो मैंने यहाँ पे दिखाया, you have the same note present. You can download it. You can use it for the exam purpose, and this is also very, very important question. So hopefully in the next class we'll come up with some new concise lecture about the ionic equilibrium. So thank you.